Movement is something that people take for granted. It's both mundane because everybody does it. Animals do it, bugs do it, but it's also very magical. It's as if you're just wishing something happened. Like I wish I had a drink of water, and somehow magically my arm moves and it orchestrates all kinds of things, and I open a bottle. So initially my thought was, like most computer scientists, that must be something very sophisticated in the brain that is going on, and we want to try to understand the neuroscience of movement. But we quickly realized that actually what makes this happen is really that the body is very sophisticated. Sensors make decisions themselves, without intervention from the rest of the brain. Your hand isn't just connected to muscles directly, but there's a complicated tendon network in the hand that basically coordinates the motion of the whole hand and responds very quickly when you make contact with objects. This sensory motor periphery isn't dumb, but it's actually doing a kind of analog computation. This is very subtle stuff, and it's not possible to have a very obvious intuition about how it works without having very sophisticated computer models. We developed basically a whole set of tools to be able to model thin solids such as tendons using something we call a strand. We can model thin skin-like structures using another new method of representing these thin sheet-like structures. The biological tissues are very thin, very soft materials. Modeling them with traditional engineering software is really not possible. So one of the things that we did is to build a whole infrastructure to be able to make computer models of this sophistication. It's really a computer representation of the human body. So we could use this model to diagnose what might be causing a problem that manifests itself externally in terms of behavior. As you know, these days you can't go to a movie without seeing all kinds of computer-generated imageries usually to make a big storm or something like that. People still go to movies to look at people. The actors, even those that are computer-generated, are controlled by motion capture-like things. My prediction is that by 2020, let's say, a lot of these people animation will also be done by simulating their bodies. So this will allow us to create like digital characters, and we already have quite a few early results of this on simulating people's skin, how they catch objects. There are a huge number of mysteries. One of the most surprising thing to me was that how muscles themselves work is still a big mystery. And this is despite like 3 Nobel Prizes being awarded in this area and so on. So we are working with a couple of groups to try to understand that a bit better. The other long-standing mystery is how this huge number of degrees of freedom that we have, like we have about 200,000 output channels, if you will, from the brain, like called motor neurons. How are they coordinated with kind of split-second accuracy to make things work? This has been, again, an open question for about 100 years, and we are starting to make some progress trying to understand that. We are probably approaching, and not anywhere near, a time when we can represent the physics of the body in great detail, and we can build a very detailed model, a computer model of a human body. So to build basically a digital human